We are wrapping up our look at the processes that form urine and adjust blood composition. In previous lectures, we saw how glomerular filtration formed the filtrate and how reabsorption of selected substances occurred at the renal tubules. Here we will conclude this segment by describing how tubular secretion works. In tubular secretion, selected substances that are in the blood are secreted into the filtrate because the filtrate at this point will make its way down to the urinary bladder and will be, or to the ureters, then to the urinary bladder, to eventually be eliminated as waste. And so we're getting rid of the unneeded substances in the blood and putting them into the filtrate so that they are eliminated when we urinate. Tubular secretion occurs almost exclusively in the proximal convoluted tubule, and substances are moved, as I mentioned in the previous slide, from the peritubular capillaries to the filtrate. So tubular secretion, kind of like tubular absorption, I think is kind of a confusing name for it, because what we're actually getting in tubular secretion is movement of substances from the blood into the filtrate. Tubular secretion is important for disposing of drugs that are in the blood plasma, eliminating nitrogen-containing wastes like urea and uric acid. So these are the breakdown products of things like proteins. Tubular secretion is important for eliminating excess potassium that's in the blood plasma, and it's also important for controlling blood pH. So if blood pH is too low, hydrogen ions or protons are secreted into the filtrate that will raise our blood pH up to a more alkaline level and allow those protons or that H plus to be eliminated in the urine. If our blood pH is too high, that is, if our blood pH is too alkaline, bicarbonate is kept in the filtrate and it is eliminated during urination.